Welcome to the channel Understanding.Concepts.Of.Physics. Hope you all are doing well. And in the previous class, we had actually studied about rotational motion. We had actually started it, and we had done almost like rigid body, axis of rotation, moment of inertia, moment of force, that is torque. So we had done these three topics in the previous class. You can just watch the videos in the playlist. And today we are going to do the couple and the inertia part. So we are going to start with understanding what couple and inertia is. Now couple is very much similar to what torque is, but with slight difference. So let's just quickly start with what couple is. Couple basically means two forces, two equal and opposite forces applied at two different points. Two equal and opposite forces applied at two different points produces a couple. Okay, now let's say, suppose if I have this one rigid body, this body is not going to change its shape and size, and let's say if I apply force at two different points, one point here and then another point here, one force going in this way and the other force going this side, they should be equal and they should be oppositely directed. Then you will find out that the body is actually moving in a rotational motion. Now this is what is called as couple. So when two forces are applied at two different points with equal magnitudes but in opposite direction is what is called as couple. So two equal and opposite forces applied at two different points produces a couple. Then comes couple is also called as moment of force sometimes, and it is sometimes also called as moment of torque as well, but most famously it is used as couple. Then couple is given by the same formula, that is it is written as a Greek character called as tau, and it's a vector quantity and it's r cross f, the same formula which we used for torque. But if you see, in when we were doing this torque, as you can see on the screen, torque has only a single force and the distance from the axis of rotation till the application of force is what is called as r. However, when we study about couple, the distance between the two forces is what is r, and f is any one of the force because they both are equal. Now as you know, a cross b is ab sin theta, so I can say that r cross f, torque is equal to r cross f, will give me rf sin theta, so torque is equal to rf sin theta. Now, and if the theta is equal to 90 degrees, okay, if theta is equal to 90 degrees, then we can say that sin 90 is 1, and if sin 90 is 1, you just write torque is equal to r into f. Then there is a sign convention which we utilize while solving the numericals of torque and couple, that is anti-clockwise torque is always taken as positive and clockwise torque is clockwise couple is always taken as negative. So if something, the body is moving in the anti-clockwise sense, then the couple is positive, and if the body is moving in a clockwise direction, then the couple is taken to be as negative. Then couple is given by right hand rule. To every cross product this rule is applicable. So whenever there is a cross product, you always apply right hand rule. So if the body is moving in this direction, like what this body is, because it is moving in the anti-clockwise sense, the couple is coming out of the page, out of the screen. So this is where the couple is. Now had this body moving in a clockwise direction, this would have been, the couple would have been going into the screen. Lastly, there is this difference where I was talking. Okay, there is a difference between a couple and a torque. A torque, if you see, torque has rotational as well as translational motion. The body actually moves in a linear path and as well as rotates. But in a couple, you always get a rotational motion. So like suppose if there is some rod or something, and if I hit this at one end, then you will find out that the body actually rotates as well as goes ahead. So this is what torque is. But suppose if I hit a rod or something like that, one from this side, one from this side, then this is going to actually rotate like this. So it is going to rotate at the same point. So this is where the couple is making a body in purely rotational motion. Then because the formula is same, the unit is same as torque, Newton meter, and the dimension will also remain same, that is L2 m1t minus 2. Then comes something called as inertia. So inertia, what is inertia? Inertia is basically a body's habit, a tendency. It's a habit. Now habit of what? Habit of remaining at state of rest or uniform linear motion till an external force is applied. Okay, so the tendency of a body to remain in a state of rest or in a uniform linear motion unless and until an external force is applied is called as inertia. So simple words में, if a body is at rest, it will always be at rest, and if a body is in motion, it will always be in motion, and the condition here is that there should be no any external force. So if this body was at rest and if you do not apply any force, then this body is going to stay for 10 days, 20 days, 10 years, 10,000 years at the same point if there is no external force. If nobody tries to pull or push, or even the table is stationary, then things will not be moving even for infinite time. However, there is another side as well. So if the body is in motion, if this is in moving, this body is moving in particular direction, then this body is never going to stop. That's what the law of inertia is. But only thing is that there should be no external force. Now because there is an external force of friction present over here, this body is going to stop. So you find out that the body stops when there is an external force, but when there is no external force, the body is never going to stop. So that's what inertia is. So inertia of a body is the tendency of a body to remain in a state of rest or in a uniform linear motion unless and until an external force is applied on it is called as inertia. Then comes who provides inertia for a body. Inertia is brought by mass of the body. So if there is a body which is heavy and if there is a body which is light, let's say these two bodies are made up of same material, they are not hollow, they are completely filled. This body is heavy, this body is light, this is light body, then this is going to have a lesser inertia. So its habit or its tendency to remain at state as rest will be lesser. Now if I pull it or push it, you will find out that this is easier to move in the sense that inertia is less because the mass is less. However, this body is heavy, so moving this body would be difficult as the mass is more, so inertia would be more. So this is where a rough idea of what it is. Right now we are not considering any friction or something. Okay, so inertia is brought by the mass of the body, and the body whose mass is less, we can say that the inertia is less, and the body whose inertia is less, we can say it would be easy to move and easy to stop. So a moving body can be stopped easy. So if a bicycle is coming towards you, it is very easy to stop. Let's say if the bicycle is coming at 20 meters per second, no, not 20 meters per second, let's say 20 kilometers per hour, then it's very easy to stop such a bicycle. You apply just small brakes of the bicycle and the bicycle stops. But let's say if this body was heavy, let's say if this was a truck and the truck is moving at 20 kilometers per hour, and in order to stop this truck you need a large amount of energy, you need large amount of force as well, because the mass is bringing the inertia, and because the inertia is less, it would be very easy to move. Smaller body, lesser mass, easy to move, and smaller body moving, you can stop it very easily as well, so it is easy to stop as well. However, when it comes to mass, when it is more, the inertia would be more, and if inertia is more, it would be difficult to move. So if it's a heavy body like a truck, you want to move it, it would be very difficult to move. However, if you want to stop a moving truck or stop a moving body which is heavy, it would be very difficult to stop as well. So that's what inertia is, and in this video we are going to discuss only these two topics, couple and inertia. Going forward, we'll be discussing more on rotational motion. Keep following the videos, subscribe this channel in case you have not done so yet, and take down your notes from the videos as well. Thank you so much. Have a nice day. Bye.